Good morning, everyone. Today's topic is file system that comes under principles of operating system and Linux concept. And it's for BCA IoT. It comes in the third unit. Normally in operating system paper, it comes in the third unit, along with the process management, memory management, and the file management. Okay, file system. So a file is a collection of related data stored in storage devices such as hard disk. An operating system manages a file using file system. So this is one of the function of operating system, file management. File system is a part of operating system which is responsible for file management. It provides a mechanism to store the data and access to the file content, including data and programs. The operating system deals with the structure, name, access, usage, protection, implementation of the files. The part of operating system that manages the file is known as the file system. The file concept. A file is a named collection of related information that is recorded on a secondary storage such as magnetic disks, magnetic tapes, and the optical disc. In general, a file is a sequence of bits, bytes, lines, or records whose meaning is defined by the file creator or the user. File represents data and programs. The data files could be numeric, alphanumeric, alphabetic, or binary. And the program files could be source program, object program, executable program, or sound recording, etc. It can be of anything. Now these are the file attributes here. Each file has a characteristics like file name, file type, date, on which date the file was created, etc. And these characteristics are referred to as file attributes. Okay, the operating system associates these attributes with the files, and in different operating system files may have different attributes also. So these are the common attributes that a file will have. So these are the explanation of those attributes. Name, the file name that we have given, identifier, that file within which the file system that is not readable. It will not be readable to us. Okay. And the type, it's the type of attribute of the file which specifies the type of the file, that is archive file, zip file, source code file, doc file, text file, etc. And the location that specifies the location of the file on the devices, the size, the current size of the file, protection, the time, date, and the user identifiers. These are the main common attributes of the file attributes. So here are some of the file operations here. The file creation and manipulations. We know creating a file, creating a directory, opening the files, reading the file, writing, renaming, deleting the file, deleting the directory. These are the file operations, but that comes under file creation and manipulation. And under file operations, we have file organization and search, file security and metadata, and file compression and encryption. So under file organization and search, we have copying the files, moving the files, etc. File security and metadata, we have the file permissions, that whether they are allowed to read or read only, or whether they are allowed to write. All these are the file permissions that we are given. And the file ownership and the file metadata. Metadata always about the details about or the information about the file. Okay, so that is data about the data. So that's called the file metadata. Then file compression and encryption, that is file compress, compression, reducing the size, encryption, that is which make it into a not readable form. All these are the different operations that becomes and that falls under the file operations. Again, the file operations are divided into file creations, file organizations, file security, file compression and encryption. So they are divided among themselves. So these are the file creation operations. We have just said file operations, file creating the directory, reading, writing, renaming the file, etc. And here we have file organization, copying, moving the file, searching for the files, and the file types. These are the large number of file types. Okay, different types of the file here. So that is a video. All these are different types of the files. And now we have the access method. How we are going to access the data. So file access method in operating system are nothing but techniques to read the data from the systems. It's not just creating the file, we have to reuse it as well. We have to use it, we have to see the content later on, we have to update the content. All these things have to be done. So first thing is to access the file in the device. So there are various ways in which we can access the file, the memory, like sequential access, direct or relative access, and index to sequential access. So we know that sequential access is a moving straight forward, and this method accesses data as one record at a time by starting from beginning of the file to its end. Moreover, the records are read and written in the order they appear in the file. So that is sequentially they will access each block by block. It will access. Once we found the correct block, it will read the data. Again, if you are searching for the data, again start from the sequentially every block it will be searching. That is sequential access. Data is read and written in the order from the beginning to the end and suitable for the log files, text files, streaming data. Then operations that we can perform is read, write and rewind. And limitations, slow access time since searching requires reading from the start. So obviously we know it reads from each and every block. It will be taking time. Example, reading a book page by the page. How we read one by one. Same with the sequential access. Sequential access mechanism is very easy to, because you're not doing anything. It just goes from one page to another, one block to another. So there is no much difficulty in accessing mechanism. And certainly its flow will become very slow. And direct or relative access, we know the direct and relative access mechanism is mostly required by the database systems. In the majority of the circumstances, we require filtered and specific data from the database. And in such circumstances, sequential access may be highly efficient. So suppose, assume that each block of storage holds 4 records and that record will be stored in the 10th block. In such situation, sequential access will not be used since it has to traverse from all the blocks to get the required block. While direct access will allow us to access the required record instantly. That is direct access and sequential access. We know sequential access each block and direct access directly go to that particular block and read the record. So usage here suitable for database and operations, read, write and seek jump to specific position need a structured format like fixed size records. So jumping to a specific page in a book, but we have to go to 99th page, means we'll turn and go to the 99th page. So files can be retrieved right away with the direct access and there is no need to traverse all the blocks here. And the direct is typically difficult to implement due to its complexity. So the other one is easy because we are reading from one by one. Here we have to check which block it is there and which record it is there in the block. We should know, then we should go to that block and read the access the data. Index is an approach accessing a similar construct on the top of the sequential mechanism and containing a link to, so it contains a link to blocks present in the memory. Okay, to locate a record in the file, we first search the index, then use the pointer to point it to concept to navigate to the corresponding file. So used as index tables to refer large database and sequence search via index and sequential read and update information. Index means is required which increases storage overhead. Again, for the index we need some memory. So an index is a book that helps to find the topics faster. We do that. Check the index and see the topic where it is. So that we don't want to flip and go through every page. It's an index table is appropriate arrangement. Records can be added in any position and when compared to other file it is costly and less efficient and it needs additional storage space. So here we have comparison of all the three. Based on access speed, flexibility and usages. So the main usages of the first sequential log files and the second one database and third one is for the DPM, that is the large file system. So we don't want to read and go through, so that you see the index and go to the access the data. I think with this we can stop here and the next topic we can continue in the next class. Thank you.